Hello all, myself Mrs. Mayuri Kangale, Assistant Professor of Mathematics from the Department of Humanities and Sciences, Walchand Institute of Technology, Solapur. Today we are going to see binomial distribution. The learning outcome is, at the end of this session, the students will be able to solve the examples of binomial distribution. The binomial distribution is a discrete probability distribution which is obtained when the probability small p of the happening of an event is same in all the trials and there are only two events in each trial. It can be applied to any experiment which satisfies these assumptions. The assumptions are: the number of trials is fixed and finite, say n. Each trial results in two ways: success, that is the occurrence of an event, or failure, that is the non-occurrence of an event. The probability of success is small p and the probability of failure is small q, such that p plus q is equals to 1 and remains same for all the trials. All the trials are independent. If x denote the number of successes in small n trials satisfying above conditions, then the probability of r successes is given by probability of x equals to r is equals to NCR p raised to r q raised to n minus r, where r runs from 1 to n. Value of small p lies between 0 to 1 and p plus q is equals to 1, and here n, p, q are called as the parameters or constants of the distribution. Now in this video we are going to see the type 3 examples. In previous videos we have seen the type 1 and type 2 examples, in which we have seen how to find the constants of the distribution and how to find the probability using the binomial distribution. Now in this video we are going to see the examples on frequency. So let us start the examples. First example is, if 10 fair coins are tossed simultaneously 64 times, then how many times would you expect to get at least 7 heads? Now to understand the example, first of all we will write the given things. Here 10 fair coins are tossed, therefore the value of small n is 10 and it is tossed 64 times. So capital N is equals to 64. The coins are fair coins, therefore the value of small p getting head is 1 by 2 and the value of small q, that is getting tail, is equals to 1 by 2, such that p plus q is equals to 1. Now here we have to find the frequency of getting at least 7 heads, that is obtained by the formula capital N into the probability of x greater than or equals to 7, for which we will first calculate the probability of x greater than or equals to 7. There are 10 coins, so we get its value by probability of x equals to 7 plus probability of x equals to 8 plus probability of x equals to 9 plus probability of x equals to 10. Now let us find out the probability for x greater than or equals to 7 using the definition of binomial distribution. We can write probability of x equals to r as NCR p raised to r q raised to n minus r. Substituting for r equals to 7, 8, 9 and 10 respectively, we can write as the probability of x greater than or equals to 7 is equal to 10c7 p raised to 7 q raised to 10 minus 7 plus 10c8 p raised to 8 q raised to 10 minus 8 plus 10c9 p raised to 9 q raised to 10 minus 9 plus 10c10 p raised to 10 q raised to 10 minus 10. Simplifying, we can rewrite it as 10c7 p raised to 7 q raised to 3 plus 10c8 p raised to 8 q square plus 10c9 p raised to 9 q raised to 1 plus 10c10 p raised to 10 q raised to 0. Substituting the values of p and q, we can rewrite it as 10c7 1 by 2 raised to 7 into 1 by 2 raised to 3 plus 10c8 1 by 2 raised to 8 1 by 2 raised to 2 plus 10c9 1 by 2 raised to 9 into 1 by 2 raised to 1 plus 10c10 1 by 2 raised to 10 into 1 by 2 raised to 0. If you observe all the four terms, we have 1 by 2 raised to 7 into 1 by 2 raised to 3. By using the laws of indices, here for the first term we can get here 1 by 2 raised to 10. Similarly, using the laws of indices, for each term we can rewrite it with 1 by 2 raised to 10. So we can write it as 120 into 1 by 2 raised to 10 plus 45 into 1 by 2 raised to 10 plus 10 into 1 by 2 raised to 10 plus 1 into 1 by 2 raised to 10. From all these four terms, we can take 1 by 2 raised to 10 common. So we can write it as 1 by 2 bracket raised to 10 into the bracket 120 plus 45 plus 10 plus 1, which gives us 176 upon 1024. On simplification, it gives us 11 by 64. Therefore, the probability of x greater than or equals to 7 is 11 upon 64. But here in this example, we have to find out the frequency. Therefore, the frequency for getting at least 7 heads is equals to capital N into probability of x greater than or equals to 7. The value of capital N is 64. So 64 into 11 upon 64 gives us 11, as 64 get cancelled from numerator and denominator. Therefore, the frequency for getting at least 7 heads is 11. Now let us go for the second example. In a sampling, the mean number of defective bolts manufactured by a machine in a sample of 20 is 2. Determine expected number of samples out of such 500 samples to contain at least 2 defective bolts. Here small n is given as 20 because the sample is of 20. The mean is given as 2. See, the mean number of defective bolts is 2. Therefore, mean is equals to 2, and the value of capital N. There are such 500 samples. So, capital N equals to 500. Let small p be the probability that a bolt is defective. For binomial distribution, mean is equals to NP. Therefore, 2 is equals to 20p, from which we can get the value of small p as 2 by 20, which is equals to 0.1. And as p plus q is equals to 1, we get the value of q as 0.9. Here we have to find out the expected number of samples which contain at least 2 defective bolts. At least 2 means minimum 2. So we can write it as the frequency is obtained as capital N into probability of x greater than or equals to 2. Now to find out this, first of all we have to find out the probability of x greater than or equals to 2. Here p is 0.1, q is 0.9 and n is 20. So, probability of x greater than or equals to 2 can be expressed as the probability of x equals to 2 plus probability of x equals to 3 and so on up to probability of x equals to 20. It can be calculated by the formula probability of x greater than or equals to 2 equal to 1 minus probability of x less than 2, that is 1 minus into the bracket probability of x equal to 0 plus probability of x equals to 1, as here we want x less than 2 and there are only two values which are less than 2, that is 0 and 1. Now pause the video for a minute and calculate the probability for x equal to 0 and x equals to 1. I hope you all have calculated the probabilities. Let us substitute it in the equation. Using the formula probability of x equals to r equals to NCR p raised to r q raised to n minus r, we can get the probability for x greater than or equals to 2 as 1 minus into the bracket 0.1216 plus 0.2702, which gives us the solution as 0.6082. That is the probability of x greater than or equals to 2. Now to find out the frequency, here we have to find out the expected number of samples having at least 2 defective bolts, that is capital N into probability of x greater than or equals to 2, that is 500 into 0.6082, which is nearly equals to 304. As the frequency is the number of samples, it cannot be in the fractional form. So rounding off to the integer, it gives us the value as 304. Thank you.